A fraction of a second. That's all it takes this Caterpillar track-type tractor with Powershift transmission to change speed, to reverse direction, giving you operating convenience, slicing cycle time, and shifts up through first, second, third, into reverse, first, second, third. And there's no difference under load. The operator uses only one lever, does no clutching. This machine shifts on the go and is built to take it. In any application, faster shifts, quick matching of power to load means more production per hour. The potential of a Powershift tractor on your job is obvious. Productivity is high because of increased machine and operator efficiency. Let's look closer at what Powershift means to the operator. A single selector lever makes all the speed and directional changes. 3 forward speeds to the right and to the left 3 reverse speeds. Spring resistance allows gear selection without looking. As a safety measure in an emergency, the lever is shoved fully forward to neutral. Another safety feature is the red-handled safety lever. It locks the drive in neutral, prevents accidental engagement of the transmission while the engine is running. Operator efficiency is further enhanced because the right hand is always free for steering the tractor or operating the cable or hydraulic control. What's behind this new Caterpillar introduction? What makes these tractors perform with such revolutionary potential? They feature an exclusive design. Caterpillar offers a brand new and different concept in Powershift transmissions, giving the advantages of both direct drive and torque converter tractors. The key to this exclusive feature is a planetary gear set with torque converter, located between flywheel and transmission. Power from the flywheel is divided. About 2/3 of the torque is sent through a converter to the transmission, and about 1/3 direct to the transmission. The planetary gears that divide the power are mounted in the engine flywheel housing. The ring gear, shown in white, is bolted to the flywheel and turns with it. Let's look at a simplified model to see how the torque split is accomplished. The ring gear is the driving member in the planetary system. As the ring gear turns, it drives planet gears, causing the planet carrier to rotate. The planet carrier is connected to the torque converter and therefore drives the converter pump shown on the right in green. Note that when the ring gear drives the planet gears, the sun gear in orange also rotates. In the actual iron, idler gears between planets and sun cause the sun gear to rotate in the same direction as the planets. The sun gear is directly connected through the hollow planet carrier shaft with the output shaft of the torque converter. Power from the sun gear, therefore, bypasses the converter. Summarizing, power from the engine is directed to the planetary in the engine flywheel housing, which divides engine output. Part goes through the torque converter to the transmission, giving Cat Powershift tractors flexibility. A torque converter automatically adjusts to the load by increasing the speed range of each gear. It also helps to prevent engine stall. The remainder of the engine output is delivered to the transmission directly, giving the solid operating feel and efficiency of direct drive machines. Now let's move back to the transmission and see how the planetary principle is used there. The transmission contains 5 sets of planetary gears: forward, reverse, and 3 to control speed. Power enters on the left and is directed to either the forward or reverse planetary set, and then on to one of the 3 planetaries controlling speed. Controls for engaging the planetary sets are located at the top of the case. A transfer gear set on the right directs power down and out the pinion to the final drive. But Back to our model to illustrate power flow through one of these planetary gear sets. Power entering the transmission drives the sun gear. The sun gear is therefore the driving member in the transmission's planetary system. The sun gear drives the planet gears, but the planet carrier does not rotate, since it is being restrained by the load on the tractor. The planet gears rotate the ring gear. No power is taken out, since the ring gear rotates but drives nothing. The transmission is now idling. The ring gear is braked when the operator engages the transmission. We peg the ring gear down to keep it from turning. Planet gears drive the carrier from which power is taken to drive the tractor. The other planetary sets work in a similar manner, determining direction and speed. Here we've added a red clutch plate to the ring gear to show how the ring gear is braked to engage the transmission. Note the clutch plate is fixed to the ring gear and moves with it. This is the matching clutch plate. When not engaged, you'll remember, the ring gear revolves freely and the planetary idles. When the operator selects this range, the clutch pack is automatically engaged, stopping the ring gear. Power is then taken out of the carrier to drive the tractor. A pack of these clutch plates controls each of the 5 planetary gear sets. Lubrication and cooling is similar to an oil flywheel clutch. Caterpillar Powershift transmissions retain both big advantages of direct drive machines. Solid operating feel, good control even when dumping a load. Next, an efficient powertrain that cuts power loss and saves fuel. Divided torque to give the advantages of both direct drive and torque converter design. That's just part of Caterpillar Powershift superiority. Now let's look at the Powershift transmission installed. The big universal joint that connects the torque converter on the left and transmission on the right permits easy, independent removal of either unit. The torque converter can be swung free after uncoupling the universal joint and removing the bolts that fasten the converter to the engine flywheel. The torque converter unit includes the planetary gear set that divides the flow of power. The same easy unit removal is possible with the transmission. The transmission is a big, rugged, 2,800-pound unit, yet precision built. It is backed by many years of development and field testing on the toughest big tractor jobs all over the country. Clean, uncluttered design makes servicing easy. The hydraulic controls that actuate gear changes can be reached through the top of the transmission case. For access to the planetaries, the transmission housing can be lifted off. Planetary gear sets can then be removed as a unit. Gears are lubricated by filtered and cooled oil delivered under pressure. Individual gears are machined to exacting tolerances to provide perfect mesh. The new powertrain is backed by the gear-making know-how of the world's leading crawler tractor manufacturer. Caterpillar has cut well over 10 million heavy-duty transmission gears. Precision control assures quality gears that are built to operate and last in big tractor operation. Even a special assembly line has been installed to manufacture the Caterpillar Powershift transmissions. After transmissions leave the line, they are moved to the dynamometer test floor for final checkout. These extra quality precautions assure long life, little downtime for this big tractor unit. 2 big points to remember. First, Caterpillar Powershift tractors offer exclusive divided torque design. This unique feature combines the advantages of direct drive and torque converter. The efficient characteristics and solid operating feel of direct drive, the flexibility of gear ranges and anti-stall features of torque converter drive. The second big point to remember, long life, minimum downtime are assured. The Powershift is a sturdy, thoroughly tested transmission designed specifically for rough track-type tractor application. Powershift by Caterpillar. Fingertip shifting in a split second under full load and no clutching. quick shifts upward to give a fast boost out of the cut. Matching load with the highest gear possible instantly means more production per hour. Powershift by Caterpillar. Tops in productivity.